All right, guys. Shh. Shh. Thank you. All right, so we'll just go through them, and then when we're done, we're done. So these are very, very similar, but not the same. What I'm telling you with number one is you will have to clean up a complex fraction in order to arrive at the limit correctly. So the first thing you always do is plug the constant in. Also, too, for your test, be very careful whether you're approaching infinity or whether you're approaching a constant. All right, so be very careful, but constants get plugged in. I'd have 5 over 5 minus 1. I'm verifying I have 0 over 0. This would be one where I'd need to clean up the complex fraction. Remember, because this isn't multiple choice, you're going to not drop your limit. It doesn't matter what direction you're coming from either, by the way. You just need to plug it in to see where you are, and this doesn't tell me where I am. So on the top, I'm going to clean up the fraction, and on the bottom, I am going to factor. So I've just found the part on the bottom that's causing the 0. It's this x minus 5. I need to locate it on the top. So remember with the complex fractions, you do Chris, and this would be a minus would be the link, cross, all over what you get when you multiply across, which is an x. And remember from our chapter 0 that it's all over x. So when you divide by that, you actually multiply by a reciprocal. It ends up putting it on the bottom. So we are going to cancel our common factors, but be careful. I just found the problem. The issue was at 5. This is called a removable discontinuity. I'm in the process of mathematically removing it, right? What do those cancel to give you? -1. Yeah, so watch that. You don't want to get a little sign error there. They are opposites. So I am taking the limit as x approaches 5 from the right-hand side of -1 over, and then I have x times x plus 5 left. So this is what I need to evaluate. Are you good with how that works? And then I just plug it in. It'd be 1 over -1 over 5 times 10, correct? So -1/50. If the question were, what value should be assigned to 5 so that the function is continuous? When I cancel this, it means I got a hole in the graph, right? It means this is the location of the hole. So if I were to rephrase the question, what value should I assign to 5? You'd say, I'm going to have f of 5 equal -1/50, so that it'd plug up the hole. But that wasn't the question for this one. It just said find the limit. All right. The next one, the tricky ones. When I plug in 0, sine of 0 is 0, so I have, that's supposed to be sine, that's supposed to be an S. Looks like a 5. Looks like 35 in theta. All right, so this would be 0 plus 0 on the top over 0 on the bottom. Normally, again, we try to factor, clean up complex fractions, conjugates. This is the tricky stuff. So it's super important on this one, your first step. Does anyone want to tell me what it is? The 3 I can't pull out front because it's not with the theta. So I can't pull it out because it's not with this. I could pull out the 1/5 because that's on the bottom. I could do that. But even before I start doing that, if it makes a heart, break it apart. Yeah, for this kind, we're going to say, well, I'm going to make this 2 separate. I'm going to take the limit as theta approaches 0 of 3 sine 4 theta over 5 theta. I'm just breaking the fraction up, plus theta over 5 theta. If it makes a heart, you can break it apart. The reason you do that is because this is the guy right here that you're going to try to mess with. If you were just to have sine 4 theta over 4 theta, I could cancel that off because it goes to 1. So now I think, Nate, like you said, pull it out front. I would take this piece and this piece, the 3/5, and go like that to get it out of the way. I'll put it in blue so you can see it. So I pull that 3/5 out front. That is totally legal. I would love it if it said sine 4 theta over 4 theta. I want it to be the sine of some stuff over the same stuff. So I'm going to go in green, and that's the beauty of math. You can go ahead and put a 4 down here if you want a 4 down here. But if I put it down there, where else must I put it? On the top, correct? But we said instead of putting it on the top and then pulling it out front, let's just pull it out front there's my 4 over 4, which is 1. This is ready to go now. I have a 12/5 out front. times, what does this whole thing go to? This is one of the harder ones. What does that whole chunk go to? 1. So it's really 12/5 times 1. So I'm going to say 12/5 times 1. This was what I was trying to kind of suck out of the problem. I could see sign of some stuff. It just wasn't over the same stuff. This will just go to 1/5. So it's really 12/5 plus 1/5. What's the answer? What's the limit? It'd be 13/5. Okay, that one might be worth some studying to know how to do one like that. It's one of the, I think it's in the top 3 of difficulty. All right, the next one up, when it says to find the limit of the f of x plus h minus f of x ones, when you put in 0 for h, you'll see I get f of x minus f of x over 0. I've got a problem with 0 over 0. I also know h is causing it. Bless you. So there's got to be an h on the top. So remember what you're going to do. You're going to take the limit as h approaches 0, and you're going to actually go do f of x plus h. That would require you to do 4 times x plus h squared minus 3 times x plus h. This guy right here is f of x plus h. Agreed? What would we have to do with this piece right here? What do I do with the x plus h quantity squared? Here's what's, yeah, thank you for saying FOIL. It's deadly to think you bring the power in. You actually have to FOIL that. If it were me, I'd take the time and even write it up above or off to the side to make sure you FOIL it correctly. My computer's being really slow. I think I have that Desmos open from last hour. So when you FOIL that, and again, I'm just leaving it off on the side here, it's going to be a 4 times x squared plus xh. So make sure you have 2 of those in the middle. And then it'll be plus h squared. That's this. Boom, boom, boom. Then it'll be minus 3x minus 3h. I'm going to have to run into this other problem. I didn't leave enough space on here. Minus 3x minus 3h. Wow. This is going to frustrate me, this being so slow. This that I just wrote out is f of x plus h. Are you good with that? I'm going to have to stretch into the other problem. Maybe I can move it over. Let me try that. That's going to get messy. No! Go back. Oh, you guys. Now it's just, no. And I'm recording. All right. I'm going to, all right. Sorry. I apologize to all you people out there. So I'm just going to clean it up over here. Are you all right with that? I had the x squared plus 2xh plus h squared. Agreed? I'm going to multiply the 4 in. So you guys help me because I can't see it now. I'm trying to see it in my head. I'd have a 4x squared plus an 8xh. Do you guys see what I'm doing? You're nodding. Awesome. You're listening. And then it'd be plus 4h squared, right? Minus 3x minus 3h. All I've done is this. What do I need to subtract from it? Minus 4x squared minus 3x. So if I subtracted that, I'd have a minus 4x squared, and then it would become a plus 3x. It's all over h. If you remember these from chapter 1, all non-h terms should cancel. And I did that so sloppily that I'm hoping it happens. Because that's gone. That has an H, that has an H, gone, gone. Did all non-H terms cancel? Yes, if that doesn't happen, you've done it wrong. And the reason I know that is because we knew H was a problem because it was causing the 0 down here. I've got to be able to factor it out of the top. Do you see how I can factor an H out of each of these? We should, so let's do that. Limit, H approaches, notice I'm keeping my limit going because I'm not replugging anything in. It'd be H times 8x plus 4H minus 3 all over h. Cancel, cancel. There's my issue. It's now gone. Does that make sense, Miles? So now I plug the 0 in for h. Remember, it's going in for h. So I end up with 8x what? Minus 3. You actually just calculated a derivative. To be honest, that's why we're doing these right now. Derivatives are limits, but there's going to be a shortcut for them, and I'm going to tell you right now because you guys are in Elk time. The shortcut is to bring the power out front and drop it down 1. 8x, right, to the first, minus, bring the power out front, 3x to the 0. There will be a shortcut eventually once we're done doing it the long way. It's kind of fun, right? So you guys have a secret. You know the answer, but you're going to have to show all the work, right? Watch. If I had changed, it's called the power rule. It's one of the most powerful rules in calculus. You found a derivative in what's called the long way, but we only do it the long way. Like if this was a 3x squared minus 2, and you went through this whole process, guess what you get? Let's make it even a 2x. Guess what you get? 6x minus 2. Yes, little tidbit for you. You'll learn it next week when we're doing derivatives. We'll do them the long way for a day just so you appreciate the short way, but we're going to have a really powerful way for doing that without all this work. It's cool. All right, next one up. The absolute value are also, again, if you're like, are they all going to be this hard? No, I chose the hardest. Why practice the easy ones, right? So I did not go through and say, oh, let's practice the one where you just plug it in and it's 4. I mean, what's the point, right? So this guy is missed a lot by people. So I'm just going to tell you, if you put the 1/3 in, you're going to get 0 over 0. So let's figure out what the issue is. Let's take the limit. What do you think I'm going to do on the top? We're going to factor, and I'm probably going to find a 3x minus 1, don't you think? I've done these enough where I know if it's causing a 0, there's probably a 3x minus 1 on the top. Hopefully I made this one correct. Oh no. I think I've got a bad problem, don't I? I might have to tweak this problem because this isn't going to work, is it? No, let's tweak this problem. Let's make that a 1. And let's just throw a fake like -4 over here. And we're going to go change the top of the fret. I think I took it off the test and only changed part of it. See, they're that close. Like I copy pasted and then I changed things in it. Does that make sense? And I think I didn't change enough. So let's change that. That'll cause us to be 3x squared minus 12x minus 1x. Let's go take this as a minus 13x and a plus 4. Let's just clean it up. All right. So right here, this is where you have to be very careful. What does this cancel to equal? One of two options. What is it? 1 or what? -1. How do you decide which one it is? Yeah, you come in at 1/3 from the left. To be honest, 0 would be a really good thing to test. Doesn't really matter how far to the left because it's, those of you who did Desmos today, the graph of those looks like this, correct? So it's 1 everywhere, so it doesn't matter whether you go way out to the left or really close like on some of them because it's not changing. So I would do a 0. If I put in a 0, I'd have a negative on the top and a what? Positive on the bottom. So this is going to equal -1. It's the same stuff over the same stuff. The only difference is the absolute value. So this is going to be the limit as x approaches 1/3 from the left of a -1 times x minus 4. Now what do I do with the 1/3? Plug it in. And I'm not going to do fraction cleanup for you guys. You should be able to do it. Let's go on to the next one. Again, I'm picking the hardest ones. All right, so that when you get to the test, you're like, easy, easy. Oh, we did one like this in Elk TIme. Medium, medium. Oh, we did one like this in Elk TIme. Are you ready for the bottom one? When I plug in a 2, what do I get? I didn't pick the easy ones where it came out nice. How do we deal with the square root ones? Multiply top and bottom by the conjugate of which one? In this case, the top. But globally, the one with the what? Square root in it. Yep, perfect. And you can throw that right on here because you're just showing me you're going in here and really just multiplying by 1. So let's go do that. Perfect. Don't drop your limit because we're just doing manipulation right now. What do I do with the top? What will I do with the top of it? Yeah, I'm going to multiply it. So the whole reason we do the root term is so we get rid of it up there. So the root times the root is just 3 minus x. When I FOIL, I don't have to do outside and inside because for conjugates, they cancel. It shouldn't be a shock to you, right? And don't FOIL the bottom. We talked about that. You want to leave that all pumped up so you can see what cancels. All right, so I'm left on the top with a 2 minus x. Correct? I feel really good about how I did this problem when I end up with a 2 minus x up there. Why do I feel really good about that, Lizzie? They cancel. If you didn't get an x minus 2 or 2 minus x, you did it wrong. Because the whole point of these is to find the issue. The issue's at 2. There has to be x minus 2 on the top, and there is. It's the opposite of it. But those cancel to leave a negative 1. So I've got the limit as x approaches 2 of a negative 1 over, right, root 3 minus x minus 1. Again, my limit's not dropped at all because I didn't replug, Andrew, but I'll do it right now. So when I put in, did I write something down wrong? Those canceled. Because what happens when I put in a 2 here? I do. I get 0 over the bottom. That won't happen on your test, by the way. It'll work out to be something nice. This is just me changing numbers and not running through the key. So the process, though, will hold throughout the whole thing. You'll get a nice answer. Are you all right like that? You might want to write yourself a note. Will be nice. I won't have it be like a 0 or a 1 over 0. The next one, what's the difference between the bottom right one, and if you don't notice it, it's going to cause some issue. There's a difference between it and the other 5. It's going to infinity. Yeah, do you think this is the kind that you need to show your work for, or the kind you can do in your head? Work, that's why I chose it for this one. The ones that you just know, when you're approaching infinity and you're like, oh, the highest powers are tied, right? If the highest powers are tied, we just steal the coefficients and LaRue makes it worth 1 point, and I'm not going to practice that. Do you remember how you do this kind? We just had a worksheet on it. What did we do? Yes. Oh, what was the O? You divide everything by the highest power on the bottom. Visually, the highest power on the bottom looks to be x squared. And this is where if you don't do your homework authentically and just copy keys, you don't remember doing it 7 times. And so those of you who said you, like in the back, you guys knew what to do, it indicates to me that you did your homework the way it ought to be done, because you did it 10 times on the homework. So I said visually what appears to be the highest term, because do you remember what the deal is? The highest term really wasn't x squared. It's the square root of x squared. What is that? X. If I'm approaching positive infinity, so I'm going to write this. If on the test, though, you're approaching negative infinity, then it's negative. So make sure you do that. But this one would be an x. All right? So when I go do this, let's see what happens. This goes to 0, right? This goes to 1. On the bottom isn't a 2, it's a root 2, right? Be careful with that, because remember we did one like that in class and I walked around the room and some of you had a 2 on the bottom. Make sure you see it's under a root. And then these cancel. There's your answer. So make sure you know on that kind how to show your work. All right. Is there one on the bottom or does it go to the back? Goes to the back. Now the kind of open-ended questions. It says explain why this function must have a 0. What am I testing you on here? The IVT. All right? So how many points will be allotted to this question? 5. I'll show you how to hit the 5. First thing you have to state is what? Since f is continuous, which all polynomials are, so this is just a parabola opening down. So you'll say since, and it says explain why it must have one. So it's going to pass the IVT. So since f is continuous on -3, -1, there's 1 point. Do you remember what chicken scratch work you had to do outside of your explanation? You do. You have to tell me what f of -3 is. Can somebody who's good at arithmetic go plug that in for me real quick? And I'll do f of -1. It'd be a negative, -1 squared minus 3 plus 10. I'm going to be at 6. How about f of -3? Someone good at arithmetic do that for me? -8? Backers? -8s? All right, we'll do that. So now you should be totally clear that to go from 6 to -8, I have to pass through 0. Did I have something wrong? Yeah, it's -1 squared. You square that first. Yep. Are we good? So I'm 100% convinced it goes through 0, right? But now you have to write it. You're going to say with f of -3 equaling -8 and f of -1 equaling 6. We're good. There's 2 points. You told me the function's continuous. You know the y values that it's going from. Has to pass through 0. What do I write next? The IVT, yeah, we did this 5 times on the homework, so that's where homework's super important in here. The IVT, you have to reference, it guarantees. Now, this is sometimes where kids don't earn the 4th point, telling me what it guarantees. At least one. What? C. Where is C? Yes, between these two. Yes, I hear you mumbling. On the x-axis, really, if I were looking at the graph, such that what has to happen? This is the hardest part to state. That means you really get it. Such that what? F of C equals 0. Perfect. Really what I'm saying is to pass from 6 to -8, right? There has to be at least one place where the height was 0. That's really what it's saying. So it needs one more thing. Because, there we go. I'm just going to write because, and it's because 0 is between 6 and -8. That's good enough. That'll get you all 5. You can write it differently, but that's kind of minimalist. Like that'll cover it all. Next, state the 3 conditions for G to be continuous at C. Number 1, what's the first thing that has to happen for first and second hour? You better have this down because I drilled you personally on this. G of C must what? Be defined. Yep. 6th hour, you're going to get specific questions asked to you on this in your groups today. Number 2, what's got to be true? Solid dot there, right? And then what has to happen? Limit x approaches C from the left of the function has to equal limit x approaches C from the right of the function. What could you write instead of that? Limit x approaches C of the function exists. It means the same thing. If I'm there from the left and there for the right, the limit exists, and vice versa. So I like this better because it gives you more of a visual, like I'm coming in from the left and I'm coming in from the right. Now, the third one has to literally seal the deal. This point has to be right there for you not to lift your pencil. That's the hardest one for kids to write. That limit, that place where I arrived as I approach C from both directions, actually has to equal what? G of C. Yep, perfect. All right, now we're going to use it for this one and be done. All right, let's go put a little bracket on here. Or do you have one? All right. So this is my function h of theta. It's piecewise. For all things not 0, by the way, I'd point at this. This means to the left and the right. If it's everywhere that's not equal to 0, it means from the left and from the right, but not there. All right? So if I'm going to use the 3-part definition, number 1, I have to see if h of 0 is defined. What is h of 0 according to this piecewise function? 4. So it passes criteria number 1. So therefore, h of 0 is defined. Boop. My smartboard doesn't like to run with that Desmos program open. I can tell it's glitchy. Number 2, I have to see what the limit is. This right here is the limit from the left and from the right. It's the limit as theta approaches 0 from both sides of 1 over cosine theta over theta. Now, when I put in a 0, I get 0 over 0. This is one of the ones that needs to be memorized. How many are there? 2. I really made you focus on one of them in class today, correct? Those of you in first and second hour. And this is the second one. What does this limit equal? Because I made you memorize it. 0. I now know the answer to the question. What's the answer to the question? Is it continuous? Here's what happens. I don't know what the graph looks like, to be honest, but I know that this guy arrives at 0 from both directions, but then it got defined up here at 4. So it looks something like, this is fake, but that's the situation. Does that make sense? So I have to explain that the dot at 4 isn't in the limit location. So see if you can write that correctly, and then we're done. you're going to say, and I have to write it because it's almost time to be done. You're going to say limit as theta approaches 0 from both sides, let's call it of h of theta, does not equal. What's it not equaling? H of 0. Maybe even below it you might want to write 0 does not equal 4. This alone doesn't cover it though because you're not tying it to the limits. This alone would. All right, I like both. So now answer the question. So what's the answer to the question? Therefore, the limit, h is not continuous, but you have to tell me what? At. It's actually continuous everywhere on the whole number line except at 0. So make sure you tell me, therefore not continuous, at h equals 0. All right, we are done. By the way, knowing this with the starred problems, I can't imagine that you can't get at least a B+, because they're very, very close. All right, awesome.